Hello everyone, myself Sai Prasad, a lecturer in AhleBait High School and the Junior College. Welcome to a series of the lectures of 9th class maths. We discussed different geometrical chapters like quadrilaterals and all in your previous classes. Today we are going to start a new chapter, that is triangles. Hope you all know what is a triangle, what are the different rules to define a triangle, how to construct a triangle, right? And you also have a basic introduction and you have learnt more about the lines and angles. Okay, based on all these concepts, we are going to study few properties of triangles. That is, you know two things, that is congruency and similarity, right? When two figures are said to be congruent, when both have same shape, right? Simple thing. And when it comes to similar, both have same shape, same size, but also what? Their ratio of corresponding sides must be same, right? Whereas in congruence both have same size and same shape. Clear? Today we are going to discuss about the different congruency rules of triangles. Okay, that is what are the parameters does a triangle have? It has 3 angles and 3 sides. Based on these things we are going to define the relationship between two triangles, that is whether they are congruent or not. If yes, what are the basic rules which has to be followed? That is popularly called as CPCT, that is corresponding parts of congruent triangles. Okay, what are those parts? Might be angles or sides. Clear? Now see here, the first basic rule, that is SAS. SA is not completely very kind of great acronym, that is just side, angle, side, right? If for two triangles, let us consider triangle A, B, C and triangle PQR. How many angles does it have? ABC. Here PQR, right? Side, angle, side, this should be in order, that is if any two sides are equal and the angle between them is equal, then we can tell that both the triangles are congruent. Okay, side, angle, side. Clear? Remember, next angle, side, angle, that is if any two angles are equal and the side between them is equal, then obviously both the triangles are congruent. Next SSS, this is very simple, you can understand, all three sides should be equal. Okay, then they can be congruent. Clear? These three rules are very simple. Next, the next rule is RHS. RH is right hypotenuse side. Okay, that is, see here, both the triangles should be right angled. Okay, both the triangles should be right angled and the hypotenuse side should be same. Okay, both the triangles should be right angled and the hypotenuse must be equal. Therefore, both the triangles can be said to be congruent. Clear? Shall we start doing problems? Let us do. Look at the question here. He gave AD and BC are equal and perpendicular to line segment AB it seems. AB is a line segment. Here AD and BC both are perpendicular to this line segment and this DC is cutting this AB at O. Then they are asking that CD bisects BA. Clear? How do we prove? Which means we have to prove that this side is equal to this side. Then we can tell that that is bisecting. Bisecting बोले तो by half, exactly in between. Clear? Is it right? How do we prove these are equal? Tell me. First write what is given. Given AB perpendicular to BC and AB perpendicular to AD. Clear? And what all is given? AD is equal to BC is also given. Clear? Now what is given? What is that we have to prove? Right to prove is BO is equal to half of AB. We can write like that, or else that can also be equal to AO. Right? Yes or no? Fine. What is that we have to do is, if you observe this one side is equal. Now I have to prove these both triangles are congruent. How do I prove? Just tell me. These both are parallel to each other, yes, and this is equal to this side, and this is one right angle triangle. Then you can tell that, see here, if you observe, these both angles are always equal, okay, that is angle BOC is equal to angle AOD by vertically opposite angles, okay, and one more, angle OAD is equal to angle OBC is equal to 90 given, right, and side AD is equal to BC, this is also given. Now if you observe angle side, okay, by angle side property we can tell that triangle, what is this, OAD is equal to triangle OBC, both are congruent to each other by AAS congruency, right, OAD OBC. You should not miss the order, first angle, then right angle, then side, angle side, clear, right. From this by CPCT we can write OB equal to OA, that is by CPCT. What is CPCT, tell me? Corresponding, yeah, corresponding parts of congruent triangles, that is the sides are equal, clear, these are one of the corresponding side, right, yes or no. Therefore if OB equal to OA, we can write O is midpoint of AB, right, therefore AB, that is CD, bisects OD, I mean CD bisects AB, clear, did you understand? See here the next question, in adjacent figure AC equal to AE it seems, where is it, AC is equal to AE, done. Next AB equal to AD, AB is equal to AD, and angle BAD is equal to angle EAC. Then we have to prove that BC equal to DE, BC equal to DE it seems, okay. Now write what all are given, right, given, right, AC equal to AE, AB equal to AD, angle BAD equal to angle EAC. What is that we have to prove? RTP, we have to prove BC equal to DE, right. Now write the triangles to which they are referring to. Let us consider triangles ABD and triangle ADE, ABC let us consider, and triangle ADE, clear. Now see here, if you observe angle BAD is equal to angle angle EAC, clear. And one more thing, this is common in both the side, right. Let us add this DAC on both sides, BAD plus angle DAC is equal to EAC plus angle DAC, okay. What is angle BAD plus angle DAC? That is nothing but this whole angle, that is angle BAC, clear. Similarly if I add these both I will get these two, that is angle CAE, clear. Now consider these two triangles ABC ADE, okay. If you observe, just check BAC is equal to CAE, isn't it, right, and the next BA is equal to AD, BA is equal to AD, right, and the next AC is equal to AE. AC is equal to AE. Now just tell me, one side is equal, one angle is equal, one more side is also equal. Therefore, we can tell this as triangle ABC is congruent to triangle ADE by which SAS congruency. Clear? Yes or no? If both the sides are equal, obviously their corresponding parts are also equal, that is BC equal to DE. Therefore, BC is equal to DE by CPCT. Is it clear? Did you understand? Shall we move to the next problem? Let's do. Look at the question here. He gave in a right angle triangle ABC, which is right angle at C, and the midpoint is M. Okay, and M is produced to D and C such that he gave that MC equal to DM. Okay, and he also told that this is a midpoint. Yes or no? M is a midpoint bole to these both are equal. Okay, now he is asking us to prove AMC is congruent to BMD. AMC BMD. Can we prove? Obviously, this side equal to this side, this side equal to this side, and this angle is equal because vertically opposite angle. Let us write that. Therefore, for first one, BM is equal to MA, right? MD equal to MC, these both are given, and angle BMD is equal to angle CMA because vertically opposite angles. Okay. Therefore, from those both we can prove that triangle AMC is congruent to triangle BMD by SAS congruency. Clear? That is it. Now look at the next second one. He is asking to prove DBC is a right angle triangle. How do we prove DBC as a right angle triangle? First thing, these both triangles are equal, right? Yes or no? From that I can tell that this angle is equal to this angle by CPCT. Okay, angle BDM is equal to angle MCA by CPCT, right? If these both angles are equal, this behaves as a transversal, then we can write that BD is parallel to AC. Clear? If BD is parallel to AC, if we consider BC is a transversal, here it is 90, obviously here also it is 90. Clear? Therefore, angle DBC is equal to angle BCA, that is equal to 90, where BC is transversal. Clear? Fine. Next, third, what did he ask? Triangle DBC is congruent to triangle ACB, it seems. DBC ACB. Okay. By CPCT, BD is equal to AC. Why? Tell me. This triangle is similar to this angle is congruent to that triangle, and the next BC is equal to BC, which is common, right? And we know that angle DBC is equal to angle BCA, which is 90, already proven here. Okay. Therefore, this is equal to this and this is common side. Therefore, by SAS, triangle DBC is congruent to triangle ACB by SAS congruency. Don't forget to write the reason in the bracket. Okay. Good. Next, fourth one. He is asking us to prove CM is half of AB. CM is half of AB. How do we prove? Tell me. We know that CM plus CM plus MD is equal to CD, right? Yes or no? Or else you can easily write it as from this proof I can write CM is equal to AB, right, and sorry, CD is equal to AB. This whole is equal to AB. Yes or no? Now just tell me what is CM? I know that CM is half of CD, right? This is CPCT. What is CD now? Tell me. Which is nothing but AB. Clear? Fine. Did you understand? Shall we move on to the next problem? Let's do. Look at the question here. He gave in a triangle ABC, AD is perpendicular bisector of BC. Perpendicular bisector means BD equal to DC. Clear? And the next, show that ABC is an isosceles if AB equal to AC. Okay. He gave that this is equal to, in which we have to prove this. Okay. Yes or no? Let us do it. How do we do? Tell me. Given triangle ADB, angle ADB is equal to angle ADC, which is 90. Clear? And the next, BD equal to DC, this is also given. Clear? And if you observe, AD equal to AD, which is common, isn't it? This is common side, this is given side, and this is angle. If you observe, triangle ADB is congruent to triangle ADC. Why? By SAS congruency. Side AD, okay, angle is this and this is BD. Therefore, by CPCT I can write AB is equal to AC by CPCT. Okay. If any two sides are equal, obviously the triangle ABC is an isosceles triangle. Is it clear? These are a few problems based on our congruency rules. Clear? Fine. This is for today. Let us meet in the next session with the more problems of 9th class. Thank you.